Hi everyone. Today I am going to present the topic impedance measurements from the subject antennas and wave propagation. In this presentation, I will explain the concept of antenna impedance, its components, matching techniques, measurement methods, and the instruments used for accurate impedance analysis. Input impedance is one of the most important parameters of an antenna system. It is defined as the ratio of voltage to current at the antenna terminals. Accurate impedance measurements is necessary to ensure maximum power transfer and efficient antenna operation. These measurements are also useful for validating antenna designs and theoretical calculations. Self-impedance refers to the impedance of an antenna operating in free space without nearby objects or interference. Driving point impedance is the practical impedance measured when the antenna is affected by surrounding objects such as the ground or nearby antennas. In real communication systems, the driving point impedance must be matched with the transmission line for efficient operation. Input impedance has two parts, resistance and reactance. The resistive component includes radiation resistance and loss resistance. Radiation resistance represents useful radiated power, while loss resistance represents power lost as heat. The reactance part is caused by stored electric and magnetic energy around the antenna. The impedance of an antenna changes with operating frequency. Antenna geometry and the surrounding environment, nearby objects can significantly affect the measured impedance values. Because of these environmental effects, impedance measurements are often carried out in the actual operating conditions of the antenna to achieve accurate results. To achieve maximum power transfer, the antenna impedance and source impedance must be conjugate matched. If matching is poor, reflections occur and standing waves are formed in the transmission line. Matching networks are designed near the antenna terminals to reduce reflections, improve bandwidth, and eliminate unwanted reactance. VSWR is a parameter used to measure the mismatch between the antenna and the transmission line. A voltage standing wave ratio value of 1 indicates perfect matching where no power is reflected back. High VSWR values indicate greater mismatch and more reflected power. Measuring VSWR is one of the first steps in antenna impedance analysis. VSWR alone does not provide complete impedance information because it only gives the magnitude of mismatch. To calculate the full complex impedance, both the magnitude and phase of the reflection coefficient are required. The phase is determined by locating voltage minima along the transmission line. Combining these measurements give the final impedance value. Modern impedance measurements are commonly performed using vector network analysis. These instruments can measure reflection coefficients and complex impedance quickly and accurately over a wide frequency range. Automated systems allow continuous monitoring of impedance changes under different environmental conditions. Traditional tools such as slotted lines and impedance bridges are still used in some applications, especially at lower frequencies. Slotted lines helps locate voltage minima, while impedance bridges compare unknown impedance with known standards. For very large antennas operating at low frequencies, scale models are often used for practical measurements. Mutual impedance describes the interaction between nearby antenna elements, especially in antenna arrays. It is measured by observing the voltage included in one antenna due to current flowing in another antenna. These interactions are important in phased arrays and multi-antenna communication systems because coupling affects overall system performance. To summarize, impedance measurements is essential for efficient antenna design and operation. Important concepts include self-impedance, driving point impedance, VSWR impedance matching, and mutual coupling. Modern instruments such as vector network analyzer provide accurate and automated measurements. Proper impedance measurement ensures maximum power transfer and reliable antenna parameters. Thank you.